This is part 7 of 6.4. A plane flies at an airspeed. An airspeed is the speed in still air, so no wind involved, if at 550 miles per hour on a straight course from airfield F. A west wind, which means a wind blowing from west to east, is blowing at 30 miles per hour. What must be the plane's bearing so that after 1 hour of flying time, the plane is due north of the airfield? So the first thing I want to draw is just a basic coordinate system. And I will have the plane, and we'll call the vector representing the plane, I'm going to call that my vector v. And the wind, that I'm going to call this vector w. And then the resultant is going to be r. Now, if this is my airfield, I want the resultant to lie right here. So I want the angle that for r to be 90 degrees. Okay? Now we know the wind is blowing from west to east, so this is going to be operating in this direction. Sorry, w vector, and that's a vector going in that direction. And if you think about it, just when you're driving, if the wind is blowing hard from the left, in order to go straight, you kind of have to steer. The wind's pushing you over to the right, so you have to steer into the wind a little bit, go to the left. So the plane is going to be flying this direction some, because the wind's going to push it back. So we'll call this our vector v. Okay? Now we know that the resultant is the sum of these two. And so we need a way of talking about both of these. Notice I'm going to be looking for the bearing. And so to get the bearing, I'm going to need to know this angle, because our bearing is going to be north some degrees west. And that degrees right there is right that, okay? So the angle from here over to here, that angle would be 90 degrees plus that angle theta. Okay? So let's start off by figuring out the magnitudes of v and w. All right? We're flying for only 1 hour. So if the plane can go 550 miles per hour but only travels 1 hour, then the magnitude of v is going to be 550. The wind is blowing at 30 miles per hour, so the magnitude there is 30. Now to add these together to get r, I need to find a way of describing both v and w. So my vector v is going to be equal to the magnitude, which is 550, times cosine of this angle, which is 90 plus theta, I, plus sine, of that same angle. Okay, now I'm going to remind you of something here. You can go through and use the identities here if you wish, but I'm going to use the cofunction identities to help simplify this. I can write 90 degrees plus theta as 90 degrees plus or minus, a negative theta. Correct? Okay. And now your cofunction identities is if you have 90 degrees minus an angle, you can use your cofunction of this angle. So I can change all of this into sine of negative theta. And I can change all of this into cosine of negative theta. So I can, using now our even odd properties, angle V, or vector V is 550 times, sine is an odd function, so I can put negative in front, sine of theta, plus cosine is an even function, so this just, it sort of absorbs that negative, cosine of theta. Of J, I and J. I always leave those off. So now distribute, and you've got negative 550 sine of theta vector I plus 550 cosine of vector of theta vector J. Okay, now W. It's on the x-axis, so our theta value for W is 0 degrees. So my vector is the magnitude, 30, times cosine of 0 degrees, I, plus sine of 0 degrees, not theta, 0 degrees, J. Well, cosine of 0 is 1, so this is 30 times 1i. Sine of 0 is 0, so that whole thing goes away. So this is just 30i. Okay, so the resultant will be these two things added together. So what I've got is, since I don't know this, and I'm supposed to add their I values together, what I have is, I'm going to be adding, think of these as your variable, and so combining like terms would look like negative 550 sine of theta plus 30i. And since this doesn't have a j, it's just plus 550 cosine of theta j. Okay? All right. So our resultant is due north. So that means I'm hoping that this angle is 90 degrees. So what I want is this. This should be my x direction, but I'm not going this way at all. I want it to be straight up and down. So I need this to equal 0 in order to get a resultant like this. So I'm going to set this equal to 0. And if I solve this for sine of theta, I get, say I move over, get negative 30, divide by negative 555, and I get positive 3 over 55. So to find theta, it's going to be inverse sine of 3 over 55, which gives me approximately 3.1 degrees. Okay, so we're just asked for the bearing. We're not asked for the magnitude. So This is our angle theta. The bearing that we're looking for is north, 3.1 degrees to the west. And this is our answer.